The bigger lesson for today is on atoms, ions, and bonding. A lot of this might be repeat from grade 9, so I think I can go through this fairly quickly, but you'll have to decide the pace. The first note, though, is probably new. It's called the octet rule. The octet rule says that when atoms form bonds, atoms will gain, lose, or share electrons in order to have 8 valence electrons. And valence electrons were defined in our video on drawing Lewis dot diagrams. They're the electrons in the outermost energy level. There are two kinds of bonding we're going to look at in grade 10. The first is ionic bonding. That's when one element loses electrons to another element, and as a result you get oppositely charged ions, because the one losing electrons will have a positive charge, the one gaining those negatively charged electrons will have a negative charge, and opposite charges attract. The other type of bonding we'll look at is covalent bonding, and that's when two atoms have a similar and fairly strong hold on the electrons, so they aren't going to give them up, and as a result they've found a way to share. And those two topics of ionic and covalent bonding are going to take us probably most of a week to go over in detail. Moving on in 3, 2, 1. You'll need a ruler for this so you can see that we're making a chart. The chart has 5 columns, double wide on 2 of them. At the very top, 7 rows. So take a moment, get your chart laid out. And what we're going to look at is in the middle section here, we're going to look at the element sodium. I'll do sodium first, then we'll come back and we'll do the other element later. So on the left-hand side, I'm going to look at the atom. And the right-hand side, I'm going to look at the ion. And we're going to see what changes. So sodium atom, first defined on the periodic table, we're looking at the very left-hand column. It's column number 1, third element down. The atomic number tells us the number of protons, and it has 11. When you turn an atom into an ion, it still has 11. The number of neutrons we get by taking the mass number. The mass number is 22.99. We round it to the nearest whole number, that's 23. We subtract the atomic number, which is 11, and that gives us 12 neutrons. And when you form an ion, you also have 12 neutrons. In a neutral atom, the number of protons and the number of electrons are the same. And so in a neutral atom, this will also be 11. However, in a sodium ion, what we find is that it had 1 valence electron, and as a result it loses the 1 valence electron. It goes down to 10. Because it had 11, the 1 valence electron is lost, so we go down to 10. As a result, the atom has no charge, none. The ion has a charge of positive 1 because it lost 1 electron. The symbol for a sodium atom is just Na, but the symbol for a sodium ion is Na with a +1 charge. That's our sodium as atom and ion. We're going to do the same thing now with bromine. Bromine you'll find on the periodic table on the second column from the right. It's down below chlorine, and its atomic number is 35. So I'll put that in here. It's got 35 protons. And again, we're going to do atom and ion. And like sodium, the number of protons does not change when you form an ion, so it also has 35. The neutrons, the mass number for bromine is 79.9, rounds to 80. 80 subtract 35 equals 45. And again, atom versus ion, it's 45 either way, because the only thing that changes between the two is the number of electrons. Neutral atom has the same number of electrons as protons, so it has 35. Bromine, if we happen to look at its Lewis dot diagram, I suppose we can do a Lewis dot diagram for each of these. I'll do it at the top, and I'll pick, we'll see if orange sticks out here. So the sodium as a Lewis dot diagram would look like that, and so we're getting rid of that 1 electron. The bromine, in contrast, because it's in group 7, Pseudo-stack diagram will look like this. It has 7 valence electrons. Because of that, what we notice is there's a gap right here. And because there's one gap, we're going to pick up 1 electron. And so we're going to go from 35 to 36. We're going to fill every one of the gaps. So in the metal, we're going to be getting rid of all the electrons on that outer level. And on the non-metals, we're going to fill in all the gaps. As a result, the neutral bromine atom will have no charge. But the bromine, because it picked up an electron, has a -1 charge. And so the symbol for bromine as the neutral element is Br, but as an ion, it's Br with a -1. Moving on to the last slide in 3, 2, 1. We're going to contrast metals versus nonmetals, and unfortunately, when I made this chart, the vertical lines didn't come through very well, so I'm just going to add them in right now. But as you can see, you're going to be making a chart which has 3 columns and 5 rows. And we're going to be contrasting metals and nonmetals. As soon as you're ready, metals on the left, nonmetals on the right. Most metals have 1 to 3 valence electrons. Most nonmetals have 5 to 8 valence electrons. There are going to be many exceptions, but that's a general rule. Next, we're going to fill in that gap in terms of what metals and nonmetals tend to do with their valence electrons. Metals tend to lose valence electrons. Nonmetals tend to gain or share. So the nonmetals will be involved in that covalent bonding we mentioned earlier. Metals and nonmetals, when put together, will form ionic bonding. So the rest of this chart deals with ionic bonding primarily. And so when we're talking about the type of ions we're forming, metals are involved in forming positive ions, nonmetals forming negative ions. The names for these ions, metals which have formed positive ions, are called cations. And I sometimes remember that because the T has that plus sign in it, so that helps me remember that the cations are positively charged. And the negative ions are called anions, A-N-I-O-N-S, not onions, anions. It's an A at the front. And sometimes I will refer to that as a negative ion as a way of keeping it straight, as opposed to the cation, which has that positive sign built into its name. That's all for now. We'll go over the ionic bonding in a lot more detail in class tomorrow. Thanks for watching.